Problem 1, here we're finding missing sides of triangles, and anytime we're trying to find a missing side, we're always going to round to the nearest tenth. So step 1 is to label the picture. So I go opposite the right angle, label the hypotenuse. Trigonometry is always about angles. So here our angle is 75 degrees 30 minutes. So drawing a line directly to the opposite side makes that the opposite and makes 6 the adjacent. So step 1 is to label the triangle. Step 2 is to identify the active sides. Here, our active sides are going to be the adjacent, which they tell you is 6, and the hypotenuse, which we're trying to solve for, is x. So step 1 is to label the triangle. Step 2 is to identify the active sides. Step 3, try to figure out, is this a sine problem, a cosine problem, or a tangent problem based on your active sides? They're giving you the adjacent, so I'll identify the A's. They're asking you to find the hypotenuse, so I'll label the H's. The only trig function that we have both parts for is cosine. So I'm going to write out the rule. The cosine of theta, the cosine of the angle, equals the adjacent over hypotenuse. So step 1 is to label the triangle. Step 2 is to identify the active sides. Step 3, determine if it's a sine, cosine, or tangent problem. Step 4 is to write out the rule. Now step 5 is to substitute the cosine of theta, the cosine of the angle. Well, here you're told the angle is 75 degrees 30 minutes. So the cosine of theta, the cosine of the angle, equals the adjacent, which is 6, over the hypotenuse, which is x. So we substitute into the rule. Now step 6 is to solve. Since our x is in the denominator of the fraction, we're going to use that switcheroo rule where we're going to take the x, take the cosine of 75/30, and switch them. So here we're going to have x equals 6 over the cosine of 75 degrees and 30 minutes. And we're going to enter that right into our calculator using the fraction template. So we're going to round to the nearest tenth. So the 6 is going to make the 9 turn into a 10 and make the 23 turn into 24. So our answer, 24.0. Problem 2. The first step is to label the triangle. So here the right angle to the opposite side becomes the hypotenuse. Trigonometry is always about the angle. So here the angle is 15/15. So directly opposite that will be the opposite, and the missing side is going to be adjacent. So step 1 is to label the picture. Step 2 is to identify the active sides. They're telling you the hypotenuse is 6. They're telling you the opposite is x. So here the active sides are hypotenuse and opposite. Step 3 is to determine whether it's a sine, cosine, or tangent problem based on the active sides. So the active sides are the hypotenuse and the opposite. So I label the h's, label the o's, and the only trig function that we have both parts for is sine. So we're going to substitute the sine of the angle, sine of theta, equals opposite over hypotenuse. So we write out the rule. We substitute in the sine of theta, the sine of the angle. The angle is 15 degrees, 15 minutes. So we have the sine of 15 degrees, 15 minutes. That equals the opposite, which is x, over the hypotenuse, which is 6. So now we're going to go about solving, and since x is in the numerator spot, we're going to go about cross-multiplying. So we're going to have 1 times x, so that's x. That equals 6 times the sine of 15 degrees, 15 minutes. So you're going to type in exactly what you see. You're going to type in 6 times the sine of 15 degrees, 15 minutes. Always type in the number parts first. So type in the number 6 first. Remember the way you get to your degrees in minutes. You press the second button and then the apps, and that pulls up the angle menu on your calculator. And to the nearest tenth, the 7 is going to kick the 5 up to 6. So the answer is 1.6. Problem 3, we label the hypotenuse. Trigonometry is always about the angle. So here the angle is 27 degrees, 50 minutes. So x is going to be opposite, 12 is going to be adjacent. Our active sides will be the opposite and the adjacent. So we're going to write out SOHCAHTOA and try to figure out which of the 3 trig functions we're going to be using based on the active sides. The active sides are the opposite and the adjacent. The only trig function that you have both parts for is tangent. So we're going to write out the rule. The tangent of theta, the tangent of the angle, equals opposite over adjacent. And we're going to substitute in the tangent of 24 degrees, 50 minutes. That equals the opposite, which is x, over the adjacent, which is 12. Since x is in the numerator spot, we're going to cross multiply. We'll put the tangent of 2450 over 1. So we're going to have 1 times x. That's just x. That equals 12 times the tangent of 24 degrees, 50 minutes. Always write and type in the number before the trig function. So on your calculator, you're going to type in 12 times the tangent of 24 degrees and 50 minutes. Look at the second decimal place, which is 5. So that's going to kick this 5 up to 6. So our answer, 5.6. Problem 4. The first step is to label the triangle. So we label the hypotenuse. Trigonometry is always about angles. So here the angle is 37 degrees, 10 minutes. So the x is going to be the opposite. 12 is then going to be adjacent. Our active sides are opposite and adjacent. So we'll write out SOHCAHTOA and try to determine which of the trig functions we have both parts for. We have the adjacent, so I'll label the a's. We have the opposite, so we'll label the x's. And the only trig function that we have both parts for is tangent. So I'm going to write out the rule. The tangent of theta equals opposite over adjacent. And now we're going to substitute. The tangent of theta. Theta is the angle, so the angle is 37 degrees, 10 minutes. Tangent of 3710 equals the opposite, which is x, over the adjacent, which is 12. Since x is in the numerator spot, we're going to cross multiply. So I'll put the tangent of 3710 over a 1. And I have 1 times x, so that's x. That equals 12 times the tangent of 37 degrees and 10 minutes. Always type in the number before the trig function. So we're going to type in 12 times the tangent of 37 degrees and 10 minutes. going to round to the nearest tenth. So look at the second decimal place, it's 9. It's going to kick the 0 up to 1. So our answer is 9.1. The next part has you finding angles of triangles to the nearest minute. Anytime you're asked to find an angle in trigonometry, we're always going to go to the nearest minute. So look at problem number 1. The first step is to label the picture. So I'll find the right angle, label the hypotenuse. Trigonometry is always about angles. So here our angle is x. So directly opposite makes the 300 the opposite and the 400 the adjacent. We identify our active sides. Here the active sides are the opposite and the adjacent. So I'll write out SOHCAHTOA and try to determine which of the 3 trig functions we're using. I'll label the opposite. I'll label the adjacent. The only trig function that we have both parts for is going to be tangent. So I'm going to write out my rule. The tangent of theta equals opposite over adjacent. And now I'm going to substitute. The tangent of theta. Theta is the angle. So here the angle is x. So the tangent of x, that equals the opposite 300 over the adjacent 400. Now when you're finding angles, once you substitute into your rule, you're essentially done with the math, and now you're going to push buttons to get your answer. So here's the sequence of buttons that you need to know to find angles of triangles. The first step, anytime you're finding an angle, is to press the second button. So we're going to press second, and since we're using tangent, we're going to press the tangent button. So second and tangent. This is what should appear on your calculator. Anytime you're finding an angle, you want to see this -1, this inverse tangent on your calculator. Then we're going to go alpha y equals and type in our fraction 300 over 400. So this is what your calculator should look like, but you'll notice the blinking cursor is now in the denominator. What you need to do is you need to move the cursor out of the denominator, so press to the right, and then close the parentheses. Then you want to go to the angle menu, which is second, and then apps, and choose option 4 for DMS. Option 4 stands for degrees, minutes, and seconds. And then when you press enter, here's what your calculator should look like. "36 degrees, 52 minutes, 11.632 seconds. Our rule for rounding says you always look at your seconds. So in this case, 11.632. If your seconds are 30 or more, you round the minutes up by 1. If your seconds are less than 30, the minutes stay the same. So you look at your seconds, it's 11 point something. 11 is less than 30, so the minutes will stay the same. So the answer, 36 degrees, 52 minutes. Problem 2, we'll label our picture. So I label the hypotenuse. Trigonometry is always about the angle. So here the angle is x, so I'll draw a line directly opposite. So the bottom is going to be the opposite. And that makes the height the adjacent. We're going to identify our active sides. So our adjacent and our hypotenuse are the active sides. we'll write out SOHCAHTOA and label our active sides. So the adjacent, the hypotenuse. So this one is going to be a cosine problem because we have the A and the H. Going to write out our rule. The cosine of theta, the cosine of the angle, equals adjacent over hypotenuse. And now we'll substitute in the cosine of the angle. Well, here we're trying to find the angle, so the angle is x. So the cosine of x equals the adjacent, 109, over the hypotenuse, 134. When you're finding an angle, once you have it substituted into the rule, then you go through your series of buttons to determine what your angle is equal to. Anytime you're finding an angle, the first button you always press is second. So we're going to press second and then our trig function, which in this problem is cosine. So we're going to press second cosine. We'll do alpha y equals and set up our fraction. So our fraction is 109 over 134. Remember to close the parentheses, which is above the 9 button, but move your cursor out from underneath the denominator before you close your parentheses. Then you want to go second apps, go to your angle menu, and go to option 4 for DMS. When you press enter, you should get 35 degrees, 34 minutes, 2.288 seconds. Look at your seconds. If it's 30 or more, you round the minutes up by 1. If it's less than 30, the minutes stay the same. So here we have 2 seconds. 2 is less than 30, so the minutes, the 34, will stay the same. So our answer is going to be 35 degrees, 34 minutes. Problem 3, we're trying to find the angle, so I'll call the angle x. We'll label our picture, so 14 is going to be the hypotenuse. Trigonometry is always about the angle. So here the angle is x, so drawing a line opposite makes the 10 the adjacent. The active sides are the hypotenuse, which is 14, and the adjacent, which is 10. So I'll write out my SOHCAHTOA and label the active sides. I have the hypotenuse. I have the adjacent, so this one is going to be a cosine because I have both parts to the rule. I'm going to write out the rule. The cosine of theta equals adjacent over hypotenuse. And now I'll substitute in the cosine of theta, the cosine of the angle, so the angle is x. That equals the adjacent, which is 10, over the hypotenuse, which is 14. Here we're finding an angle, so we're going to go through the button sequence to calculate what our angle is. When you're finding an angle, you always press the second button first, and then your trig function. So here, since we're using cosine, we're going to press second and then cosine. Always make sure when you're finding an angle, you see the -1, the inverse cosine notation there. We'll enter our fraction, which is 10 over 14, and then close the parentheses. Then second apps, the angle menu, and then option 4 for DMS. So you should get 44 degrees, 24 minutes, 55.111 seconds. You always look at your seconds. If it's 30 or more, you round up. So here, since our seconds are 55, 55 is bigger than 30, so we're going to round the minutes up by 1. So our answer is going to be 44 degrees, 25 minutes. Our next problem is a reciprocal trig function problem. And the first step is going to be to determine what our missing side is. So in order to do that, we're going to do the Pythagorean theorem. A squared plus b squared equals c squared. The most important letter in the Pythagorean theorem is letter C, which is the hypotenuse. So letter C is going to be 16. So I'm going to go a squared, 8 squared, plus b squared, that's x squared, that equals 16 squared. Do on your calculator, 8 squared is 64. Do on your calculator, 16 squared is 256. So we're going to solve for x by subtracting 64 on both sides. So I have x squared equals 256 minus 64, or 192. And then I'm going to take the square root of both sides. So x is going to be equal to the square root of 192. And I'm going to have to simplify that. I'm going to look for the biggest perfect square that goes into 192 evenly. Remember your list of perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So this is your list of perfect squares that you want to look for. And what you're going to do is you're going to start dividing by these numbers to see if they go in evenly. So at first glance, when you do 192 divided by 4, that goes in 48 times. So you think that's the right answer. But you're looking for the largest perfect square. When you do 192 divided by 9, you get a decimal. That's not good. You do 192 divided by 16, you get 12. So maybe you think 16 is the biggest perfect square that works. You want to keep dividing in until you find the biggest perfect square that goes into 192 evenly. 64 is going to be your answer. 64 times 3 is 192. So I'm going to break up radical 192 into radical 64 times radical 3. So you want to look for the biggest perfect square that works. The square root of 64 is the number 8. So x, the missing side of the triangle, turns out to be 8 radical 3. So I'll write that in for that missing side. So now I'm going to go about determining these 6 trig functions. And remember, trigonometry is always about the angle. So the first one asks you for the cosine of angle n. So angle n is up top. I'm going to label my picture. The 16 is still the hypotenuse. That doesn't change. But since my angle is n, the opposite is 8 radical 3. The adjacent is going to be 8. So for cosine, I'll write out SOHCAHTOA. Cosine is adjacent over hypotenuse. So adjacent is 8. Hypotenuse is 16. So 8 over 16 gives you 1/2. The next one is the sine of angle n. So my picture still works because the angle is n. Sine is equal to opposite over hypotenuse. So opposite is 8 radical 3. Hypotenuse is 16, so I have 8 radical 3 over 16. 8 goes into 8 once, 8 goes into 16 2 times, so I have 1 radical 3, which is just radical 3, over 2. Since the radical is in the numerator, that's okay for an answer. The tangent of angle n, again I'm using angle n, so my picture is okay. Tangent is equal to opposite over adjacent. So here the opposite, 8 radical 3, the adjacent, 8. So it's 8 radical 3 over 8, but then 8 goes into 8 one time. So the 1's cancel, and you're left with radical 3. The next 3 deal with angle P. So I'm going to have to go back and relabel my picture with angle P. So since the angle is angle P, the hypotenuse never changes. That's still going to be 16. But now my opposite angle P is going to be 8, and my adjacent is going to be 8 radical 3. So to find the sine of angle P, that's so that's opposite over hypotenuse. Here opposite is 8, hypotenuse is 16, so 8 over 16 is a half. The cosine of angle P, that's adjacent over hypotenuse, that's going to be 8 radical 3 over 16. But 8 goes into 16 2 times. So there your answer is radical 3 over 2. And then the tangent of angle P, that's the TOA, that's opposite over adjacent. So that's 8 over 8 radical 3. Well, 8 goes into 8 one time. So now I have 1 over radical 3. But now that's a problem because the radical 3 is in the denominator. So I'm going to multiply both the top and the bottom by radical 3. So I have 1 radical 3, which is radical 3. On the bottom, I have radical 3 times radical 3, which is radical 9. But the square root of 9 is just the number 3. So I'm going to have the number 3 on the bottom and then radical 3 on top. So radical 3 over 3. Problems 7, 8, and 9 also deal with angle P, so my picture for opposite, adjacent, and hypotenuse is okay. But now I'm dealing with the reciprocal trig functions. So the reciprocal of cotangent for number 7, the reciprocal is tangent. So what I'm going to do is I'm going to find the tangent of angle P, which I said was radical 3 over 3, and I'm going to flip it. So that's going to become 3 over radical 3. So that's going to be an issue again because I have the radical in the denominator. But if you're clever, if you know that the reciprocal of cotangent is tangent, the tangent was 8 over 8 radical 3, or when the 8's canceled, 1 over radical 3. So I can just take the reciprocal of 1 over radical 3 to get radical 3 over 1. So that's going to be my answer. If I took the reciprocal of radical 3 over 3, I could rationalize the denominator. Here I would have 3 radical 3 over radical 3 times radical 3 is the number 3, and then these 3's would cancel. So either way, I'm left with radical 3 over 1 or just radical 3 as our answer. So you have to remember that the reciprocal of cotangent is tangent. For number 8, we have the cosecant of P. Cosecant begins with a C, so its reciprocal is going to be with an S. So what I'm going to do is I'm going to go and find the sine of angle P. Remember, we're using angle P. Here, the sine of angle P was 1/2. So I'm going to take the reciprocal of 1/2. I'm going to flip 1 over 2 to get 2 over 1. So here, the cosecant of P is the number 2. That's your answer. So remember, the reciprocal of cosecant is sine. Finally, for number 9, the secant of angle P. Well, secant is S, so the reciprocal is going to be C, or cosine. So I'm going to find the cosine of angle P, which we said was radical 3 over 2, and I'm going to flip it to get 2 over radical 3. But that's going to be a problem because we have the radical in the bottom. So if we were smarter, what we could have done is try to look and see if anywhere else wouldn't cause a problem. And unfortunately, 8 radical 3 over 16 would also put the radical 3 in the bottom. So there's no shortcut. Here we just have the reciprocal of radical 3 over 2, which is 2 over radical 3. So I'll have to multiply both the top and the bottom by radical 3 to get 2 times radical 3, or 2 radical 3, over radical 3 times radical 3, which is the number 3. So that's what the secant of angle P turned out to be. And here are the answers to the calculator problems on the last page.